Okay, so I'm gonna be going over. Let me just. No, which one did I do last time? 1.6. Yeah. So I'm gonna be going over 1.7 and whatever else I end up going through today. I know I'm probably gonna do a bunch of videos today. I think. I think I'm gonna do some videos later on reverse engineering and DMA or something along those lines. All right. Anyways, okay. So C++ reserves a lot of or a set of 92 words out of C++ 23 for its 7 years. These words are called keywords or reserved words, and each of these keywords has a special meaning within the C++ language. Here is a list of all the C++ keywords through C++ 23. I'm not going to be reading through all this. Um, the keywords marked C++ 20 were added in C++20. If your compiler is not C++20 compliant, it doesn't have C++ functionality, but it's turned off by default. Or it does have C++. Yeah, these keywords may not be functional. C++ also defines special identifiers, override, final import, and module. These have a specific meaning when used in certain contexts, but are not reserved otherwise. You've already run across some of these keywords, including int and return. Along with a set of operators, these keywords and special identifiers define the entire language of C++. Preprocessor commands excluded. Because keywords and special identifiers have special meaning, your IDEs will likely change the text color of these words to make them stand out from their identifiers. By the time you are done with this tutorial series, you'll understand what almost all these words do. Give me a second. Okay, I'm back. Alright, so so the keywords marked C++20 were added, okay. When we do this tutorial series, you understand what almost all of these words do. Identifier naming rules. As a reminder, the name of a variable or function type or other kind of item is called an identifier. C++ gives you a lot of flexibility to name identifiers as you wish. However, there are a few rules that must be followed when naming identifiers. The identifier cannot be a keyword. Keywords are not reserved. The identifier can only be composed of letters, lower uppercase numbers, and the underscore character. That means the name cannot contain symbols except the underscore, nor white spaces or tabs. The identifier must begin with a letter, lower uppercase, or underscore cannot start with a number. C++ is case sensitive and thus distinguishes between lower and uppercase letters. N value is different than N value. It's different than N value. Identifier naming best practices. Now that you know how you can name a variable, let's talk about how you should name a variable or function. First, it's a convention in C++ that variable name should begin with a lowercase letter. The variable name is a single word or acronym. The whole thing should be written in lowercase letters. Integer value, conventional. Int value, unconventional. Unconventional, unconventional. See your psychiatrist. Yeah, that's pretty funny. Most often, function names are also started with a lowercase letter. Although there's some disagreement on this point, we'll follow this convention since function main, which all programs must have, start with a lowercase letter. Let's do all the functions in the C++ standard library. Identifier names that start with a capital letter are typically used for user-defined types, such as structs, classes, and enumerations, all of which we will cover later. It's the variable or function name. If the variable or function name is a multi-word, there are two common conventions. Words separated by underscores, sometimes called snake underscore case, or insert cap, sometimes called camel case, since the capital letters stick up like the humps in a camel. Yeah, I'm gonna be doing a snake case or underscores whenever I do coding, because any of my videos I've been doing coding on. I'm gonna be doing snake case, like, well, I'm pretty sure I changed this, I just forgot to forget to save it. Let me fix this real quick. Yeah, but from now on, I'm gonna be doing snake case. Yeah. Anyways, I'm thinking it looks better. Conventional intercaps with camel case. So camel case is when you just add capital letters to the start of words after your first word. Okay, yeah, no white space, unconventional, yeah. In this tutorial, we will typically use the intercap approach because it's easier to read. It's easy to mistake an underscore for a space in dense blocks of code, but it's common to see either. The C++ standard library uses the underscore method for both variables and functions. Sometimes you'll see a mix of the two. Underscore is used for variables, intercap is for functions. It's worth noting that if you're working in someone else's code, is generally considered better to match the style of the code you're working in than to rigidly follow the name conventions that out above. Working in an existing program, use the conventions of that program, even if they don't conform to modern best practices, and use modern best practices when you're writing new programs. Second, you should avoid naming your identifiers starting with underscore, as these names are typically reserved for operating system, library, and or compiler use. Third, your identifiers should make clear what the value they are holding means, particularly if the units aren't obvious. Identifiers should be named in a way that would help someone who has no idea what your code does be able to figure it out as quickly as possible. In 3 months, when you look at your program again, you'll have forgotten how it works, and you'll think to yourself, picking variable names that make sense. However, giving a trivial variable and a really complex name impedes overall understanding of what the program is doing, almost as much as giving a widely used identifier an inadequate name. Therefore, a good rule of thumb is to make the length of an identifier proportional to how widely it is used. An identifier with a trivial case or trivial use can have a short name, for example, such as I. Identifier that is used more broadly, for example, a function that is called from many different posts in a program, should have a longer, more descriptive name. For example, instead of open, try open file on disk. So int count, what does C before count stand for? I'm not gonna really read into this shit. In any case, avoid abbreviations unless they're common / unambiguous. Although they reduce the time you can write your code, they make your code harder to read. Code is read more often than it's written. Time you saved while writing the code is time that every reader, including the future you, wastes when writing or reading it. If you're looking to write code faster, use your editor's autocomplete feature. For variable declarations, it is useful to use a comment to describe what a variable is going to be used for, or to explain anything else that might not be obvious. For example, say we've declared a variable named number of chars that is supposed to store the number of characters in a piece of text. Does the text hello world have 10, 11, or 12 characters? It depends on whether we're including white space or punctuation rather than naming the variable. I can already tell you hello world has 12 characters, I'm pretty sure. Rather than naming the variable number of chars including white space and punctuation, which is rather lengthy, a well-placed comment on or above the declaration line should help you to figure it out. Quiz time. Based on how you should name a variable, indicate whether each variable name is conventional, follows best practices, unconventional. Compiler will accept it does not follow best practices, or invalid will not complete and why. Integer sum with brackets, assume it's obvious what we're summing. Yeah, that makes sense. Okay, conventional. Int underscore apples, you do not want to do that because libraries operating systems use the underscore before their variables. Int value, it's unconventional. Int my variable name, unconventional, or well, that just would give you an error, not like this isn't allowed. Int total customer is unconventional because the first word is capitalized. Int void, unconventional or invalid. Yeah, void is a keyword, so you can't use that. That's what I was thinking, but I can't remember what the words were for it. Int num fruit, that's conventional, that should be camel case. Int 3 sum, unconventional or invalid. I think it's invalid because you can't have it start with a number or something like that. But yeah, variable names cannot start with a number. Int meters underscore of underscore pipe, conventional. Yeah. Pretty easy. I'll drink some water real quick. Alright. Okay, so whitespace and basic formatting. Whitespace is a term that refers to characters that are used for formatting purposes. In C++, this refers primarily to spaces, tabs, and new lines. Whitespace in C++ is generally used for three things: separating certain language elements inside text and formatting code. Some language elements must be whitespace separated. The syntax of the language requires that some elements are separated by whitespace. This mostly occurs when two keywords or identifiers must be placed consecutively so the compiler can tell them apart. For example, a variable declaration must be whitespace separated. Int x int and x must be separated, obviously. If we typed int x instead, the compiler will interpret it as an identifier, and the compiler doesn't know what the identifier int x is. There's another example: a function's return type and name must be whitespace separated. So the return type is int, the name is main, it needs to be separated. When whitespace is separated as a separator, whitespace is required as a separator. When whitespace is required as a separator, the compiler doesn't care how much whitespace is used as long as some exists. The following variable definitions are all valid. As discussing, in certain cases, new lines are used as a separator. Single line comments are terminated by a new line. An example of doing something like this will get you in trouble. Standard character output, hello world, is a part of the comment. And this is not part of the comment. Okay. Preprocessor directives. Hashed, for example, the includes IO stream must be placed in separate lines. Okay. Quoted text takes the amount of white space literally. Inside quoted text, the amount of white space is taken literally. Okay. Sure. Is different than, yeah. New lines are not allowed in quoted text. Standard C out. Hello world, not allowed. Quoted text separated by nothing but white spaces, or white spaces, tabs, and new lines would be concatenated. So they'll be just added onto each other. Using white space to format code. White space is otherwise generally ignored. This means we can use white space wherever we like to format our code in order to make it easier to read. For example, the following is pretty hard to read. Hashtag include library IO stream int main stand it puts a block on the same line of the code. That's so disgusting. And it doesn't make them, yeah, the following is better, but it's still pretty dense. Yeah, the following is even better. Yeah, this is how I'm gonna do it. I just can't even look at that, but it makes my eyes hurt. Statements may be split over multiple lines if desired. Not doing that, it's disgusting. It can be useful for particularly long statements. Unlike some other languages, C++ does not enforce any kind of formatting restrictions on the programmer. For this reason, we say that C++ is a white space independent language. This is a mixed blessing. On one hand, it's nice to have the freedom to do whatever you like. On the other hand, many different methods of formatting C++ programs have been developed over the years, and you will find sometimes significant and distracting disagreement on which ones are best. Our basic rule of thumb is that the best styles are the ones that produce most readable code and provide the most consistency. Here are our recommendations for basic formatting. It's fine to use either tabs or spaces for indentation. Most IDEs have a setting where you can create a tab press into the appropriate number of spaces. Developers prefer spaces tend to do so because it ensures that code is precisely aligned as intended regardless of which editor settings are used. Proponents are using tabs wonder why you wouldn't use a character design to do an indentation for indentation, especially as you can set the width to whatever your personal preference is. There's no right answer here. And debating is like arguing whether cake or pie is better. Ultimately comes down to personal preference. Either way, we recommend you to set your tabs to 4 spaces worth of indentation. Some IDEs default to 3 spaces of indentation, which is fine too. There are 2 conventional styles for functional braces. For function braces, many developers prefer putting the open curly brace in the same line of the statement. The justification for this is it reduces the amount of vertical white space, as you aren't devoting an entire line to an opening curly brace. So you can fit more code on the screen. This enhances code comprehension as you don't need to scroll as much to understand what the code is doing. However, in this tutorial series, we'll be using the common alternative where the open brace appears on its own line. This is what I'm going to be doing too. I do new line open braces. So, or I put my block on a new line instead of on the line by function. This enhances readability and is less error prone since your brace pairs should always be indented at the same level. If you get a compiler error due to a brace mismatch, it's very easy to see where. Each statement within curly braces should start one tab in from the opening brace, the function it belongs to. For example, int main curly braces standard cell. Okay, tab in one tab, spaces, and has to meet you. 1, 2, 3, 4. The line should not be too long. Typically, 80 characters has been the de facto standard for the maximum length the line should be. The line is going to be longer, it should be split at a reasonable spot into multiple lines. It can be done by indenting each subsequent line with an extra tab, or if the lines are similar, by aligning it with the line above, which is easier to read. That looks fine. I would probably just do another standard cout command. But yeah, this makes your line easy to read. On modern widescreen monitors, it also allows you to place two windows with similar code side by side and compare them more easily. Consider you're keeping your lines to 80 characters or less in length. Many editors have a built-in feature or plugin such extension that will show a line called a column guide at a given column. For example, at 80 characters, so you can easily see when your lines are getting too long. To see if your editor supports this, do a search on your editor's name plus column guide. A long line is split with an operator tag. For example, the output operators or bitwise operators or the plus operator. The operator should be placed at the beginning of the next line, not the end of the current line. Okay, this helps make it clear that subsequent lines are continuations of the previous lines. Allows you to align the operators on the left, which makes for easier reading. And use whitespace to make your code easier to read by aligning values or comments or adding spacing between blocks of code. Harder to read. Cost equals 57, price per item equals 27, value equals 5, item equals 17. Easy to read. Cost equals 57, price per item. I mean, they both are easy to read for me. I just read it left to right, so that's what's correct. Harder to read. Standard cout, hello world. Character output lives in the IOcean library. I know that. Very nice to meet you. Just comment with code hard to read. Okay, easy to read. I guess that makes it better. Harder to read. I'll start doing it like this from now on. Harder to read. Libraries, comment with code hard to read. Question and all done together. Easy to read. We'll follow these conventions throughout this tutorial, and they will become second nature to you. As we introduce new topics to you, we will introduce new style recommendations to go with those features. Ultimately, C++ gives you the power to choose whichever style you're most comfortable with or think is best. However, we highly recommend you utilize the same style that we use for our examples. It has been battle tested by thousands of programmers over billions of lines of code, and it is optimized for success. One exception, if you're working in someone else's code base, adopt their style. It's better to favor consistency than preferences. Best practice when working in an existing project, be consistent with whatever style has already been adopted. Automatic formatting. Most modern IDEs will help you format your code as you type it in. For example, when you create a function, the IDE will automatically indent the same statements or the statements inside the function body. However, as you add or remove code or change the IDE's default formatting or paste in a block of code that is default formatting, won't get messed up. Fixing the formatting for part or all of a file can be a headache. Fortunately, modern IDEs typically contain an automatic formatting feature that will reformat either a selection highlighted with a mouse or an entire file. Visual Studio users. In Visual Studio, the automatic formatting options can be found under Editor, Advanced, Format Document, Edit, and Edit, Advanced, Format Selection. What did it say it is? Visual Studio, the automatic formatting can be under Edit. So Edit, Advanced, Format Document. Okay. What did they even do? I don't even know what that thing did. Whatever. Maybe, I think it was already pretty well formatted, so I didn't see anything change, but maybe something changed, I don't know. Best practice. Using the automatic formatting feature is highly recommended to keep your code's formatting style consistent. A style guide is a concise, opinionated document containing sometimes arbitrary programming conventions, formatting guidelines, and best practices. The goal of the style guide is to ensure that all developers on a product are programmed in a consistent manner. Some commonly referenced C++ style guides include this core guide maintained by, I'll look at this. Generally favor the C++ core guidelines that are up to date and widely applicable. Control K or Control D performing. Yeah, no, that doesn't matter. Just wanted to share something from VS Code users. If you don't know where to find a setting, just open settings, Control plus, and then type out some keywords and it does a job of finding matching. Okay, cool. Alright. Introductions to literals and operators. We're for 21 minutes, not too bad. Yeah, I can probably keep on going. Alright. Okay, consider the following two statements. Standard character output, hello world, integer x, with the value of 5. What are hello world and 5? They are literals. A literal, also known as a literal constant, is a fixed value that has been inserted directly into the source code. Literals and variables both have a value and a type. Unlike a variable, whose value can be set and changed through initialization and assignment, respectively, the value of a literal is fixed. 5 is always 5, this is why literals are called constants. To further highlight the difference between literals and variables, let's examine this short program. So standard character output 5, print the value of a literal, integer x, the value of 5, standard character output, the integer x, print the value of a variable, return 0. On line 5, we're printing the value 5 on the console, and the compiler compiles it, so we generate code that causes standard character output to print the value 5. The value 5 is compiled into the executable and can be used directly. On line 7, we're creating a variable named x and initializing it with the value 5. The compiler will generate code that copies literal value 5 into whatever memory location is given to x. On line 8, we print x. The compiler will generate code that causes standard character output to print the value at the memory location of x, which is the value 5. I'm just thinking about this like in terms of like how it would actually look within like assembly, and it's pretty cool to think about. Like when we're printing out x, it says it's gonna print out the value at the location of x. So there'd be brackets around this, and it'd be like a d word pointer to x, which the brackets around it will dereference whatever's within the brackets, getting the value of that address. And anyways, it doesn't matter. I just thought it was cool. But thus, both output statements do the same thing. Print the value 5 in the case of a literal. The value 5 can print it directly. In the case of the variable, the value 5 must be fetched from the memory variable represents. It also explains why a literal is a constant, while the variable can be changed. A literal's value is placed directly in the executable, and the executable itself can't be changed after it is created. The variable's value is placed in memory. The value of memory can be changed while the executable is running. Key insight. Literals are values that are inserted directly into the source code. These values usually appear directly in the executable code, unless they're optimized out. Objects and variables represent memory locations that holds values. These values can be fetched on demand. Related concepts. Talk more about literals in lesson 5.2 literals. Operators. In mathematics, an operation is a process involving 0 or more input values, called operands, that produce a new value, called an output value. Specific operation to be performed has been denoted by a symbol called an operator. For example, as children, we all learn that 2 plus 3 equals 5. In this case, the literal 2 and 3 are the operands, and the symbol plus is the operator. It tells us to apply mathematical addition on the operands to produce the new value 5. Yeah, so operands are just what is being operated on, which makes sense. It's called an operand. And then the operator is obviously, multiplication, division, addition, subtraction, powers, whatever you want to do. In C++, operations work as you expect. For example, standard character output of 1 plus 2. In this program, the literals 1 and 2 are operands to the plus operator, which produces the output value 3. The output value is then printed to the console. In C++, the output value operation is called a return value. You are likely already quite familiar with standard arithmetic operators from common usage in mathematics, including addition, subtraction, multiplication, and division. In C++ assignment, equals is an operator as well as an insertion, as are insertion and extraction, and equality. While most operators have symbols for names, for example, plus or equality, there are also a number of operators that are keywords, for example, new, delete, and throw. Others note, for reasons that will become clear when we discuss operators in more detail, for operators that are symbols, it is common to append the operator symbol to the word operator. For example, the plus operator will be written as operator plus, and the extraction operator will be written as operator extraction. Number of operators or operands that an operator takes as input is called the operator's arity. Whatever that is, few people know what this word means, so don't drop it in a convention. Expect anybody to have any idea what you're talking about. Operators in C++ come in 4 different arities. Unary operator acts on one operand. An example of a unary operator is the... let me search this up real quick, make sure I'm saying this right. Let me pull up the transit.
Unary.
Okay, so unary. Excuse me. Unary operators act on one operand. An example of a unary operator is the subtraction operator. For example, given a -5, operator minus takes a literal operand 5 and flips its sign to produce a new output value, -5. Binary operators act on 2 operands, often called left and right, as the left operand appears on the left side of the operator and the right operand appears on the right side of the operator. An example of a binary operator is the plus operator, for example, or addition. Example, given 3 plus 4, operator plus takes a left operand 3 and the right operand 4 and applies mathematical addition to produce new output value 7. The insertion operator and extraction operators are binary operators taking standard character output or standard character input on the left side and the value to output or variable to input on the right side. Ternary operators act on 3 operands. There's only one of these in C++, the conditional operator, which we'll cover later. Nullary operators act on 0 operands. There's only one of these in C++, the throw operator, which we'll cover later. Note that some operators have more than one meaning depending on how they are used. For example, operator subtraction has 2 contexts. It can be used in unary form to invert a number sign. For example, to convert 5 -5. Or vice versa, it can be used in binary form to do subtraction. For example, 1 - 3. Chaining operators. Operators can be chained together such that the output of one operator can be used as the input for another operator. Example, given the following 2 times 3 plus 4, the multiplication operator goes first, converts the left operand 2 and the right operand 3 into return value 6. Becomes the left operand for the plus operator. Next, the plus operator executes and converts the left operand 6 and right operand 4 into a new value of 10. It just goes, it either goes left to right, or it goes near the PEMDAS, like parentheses, whatever the fuck the rest of it is. We'll talk more about the order in which operators execute when we do a dive into the topic of operators. For now, it's enough to know that the arithmetic operators execute in the same order they do in standard mathematics: parentheses first, and exponents, and multiplication, division, and addition and subtraction. This ordering is sometimes abbreviated PEMDAS or expanded to the mnemonic. Please excuse my dear Aunt Sally. Yeah. Authors note, in some countries, PEMDAS is taught as PEMDAS, BEDMAS, BODMAS, or BIDMAS instead. Return values and side effects. Most operators in C++ suggest to use their operands to calculate a return value. For example, -5 produces a return value -5, and 2 plus 3 produces a return value 5. There are a few operators that do not produce return values, such as delete and throw. We'll cover what these do later. Some operators have additional behaviors. An operator or function that has some observable effect beyond producing a return value is said to have a side effect. For example, x = 5. The side effect of assigning value 5 to the variable of x. The change value of x is observable. For example, by printing value x after the operator has been finished executing. Indicator output 5 has the side effect of printing 5 to the console. You can observe the fact that 5 is when it printed to the console even after standard character output. What is this? Is it insertion operators or extraction? Insertion. 5 has finished executing. Nomenclature. In the common language, the term side effect is typically used to mean a secondary, often negative or unexpected result of some other thing happening, such as taking medicine. For example, a common side effect of taking oral antibiotics is diarrhea. As such, we have to think of side effects as things we want to avoid, or things that are incidental to the primary goal. C++, the term side effect has a different meaning. It is an observable effect of an operator or function beyond producing a return value. Assignment has the observable effect of changing the value of an object. It's considered a side effect. We can use certain operators, for example, the assignment operator, primarily for their side effects rather than the return value those operators produce. In such cases, the side effect is both beneficial and predictable, and is a return value that is often incidental. For transferters, for the operators that we call primarily for their return values, for example, operator plus or operator multiplication, it's usually obvious that their return values will be, for example, the sum or product of these operands. For the operators, we call primarily for their side effects. For example, operator assignment or operator insertion. It's not obvious what return value they produce, if any. For example, what return value would you expect variable x with initialization of 5 to have? Both operator assignment and operator insertion when used to output values to the console return their left operand. Thus, x equals 5 returns x, and standard character output 5 returns standard character output. This is done so that these operators can be chained. For example, x equals y equals 5. The value says x equals y equals 5. First, y equals 5 assigns 5 to y, and this operand then returns y, and then be assigned to x. Standard character output hello. Operator's world value is the standard character output hello. Then world. This first prints hello to the console. The operand returns standard character output, which can be used to print world to the console as well. We'll talk more about the order in which operators evaluate in lesson 6.1, operator precedence and associativity. Basically, it just goes by what is done first. Like, it'll do y equals 5 first, and then it'll do x equals y. I mean, this is pretty, like, self-explanatory. If you don't already think this way, I don't even know what's going on. Like, you would think that you already think this way. It just goes with whichever one should come first. Maybe it's just because I've been doing it for a while that's the way I think. I don't know. But that all seemed pretty obvious to me. For each of the following indicate what output they produce. Then the character output 3 plus 4. So this would be what output they produce. Well, it'll produce 7 within the console, and then a new line character. So yeah, that's pretty obvious. Standard character output 3 plus 4 minus 5. This will produce 7 minus 5 equals 2. Obviously. Character output 3 times 4 is to be 12 plus 2, so 14. For addition, obviously. Okay, so extra credit, so it's initializing the variable x with 2. It's in the character output x equals 5. So it's going to print out 5. X equals 5 assigns the value of 5 to x and returns x. The value of 5, x, now 5, when printed to the console. Pretty obvious. Definitive expression. It's pretty quick one. I'm gonna go to the bathroom real fast. Where is the pause button? Alright. Sorry, I'm back. Oh, I guess, what am I saying? Sorry, I'm back, as if y'all even know I was gone. I mean, y'all knew I was gone. I paused the thing, but like, it was like a flash for this little video, so I mean, Discord. I wouldn't get a protein bar real quick, I was starving. Okay, excuse me. Alright, so consider the following series of statements, each of which defines a variable and initializes it. So this is a function with a return type of integer 5. It returns the value of 5. Okay. return type and function main declares 5 integers. It's just a bunch of random bullshit. This int e calls the function 5, which returns value 5. Okay, that's pretty funny, not gonna lie, I've never since I did it. Note that the initializers above make use of a variety of different entities, literals, variables, operators, and function calls. Somehow C++ is converting all these different things to a single value. Like me uses the initial value of the variable. What do all of these initializers have in common? They make use of an expression. In general programming, an expression is a non-empty sequence of literals, variables, operators, and function calls that calculates a value. The process of executing an expression is called evaluation, and the resulting value produced is called the result of the expression, also sometimes called the return value. Advanced rooters. In C++, the result of an expression is one of the following: a value, most commonly, an object or a function. We discuss expressions that return objects in lessons 12.2. What value category values and R values? It's a far way away. Noting nothing. These are the result of non-value returning functions calls, which are called void. So if I did void 5, it'd be something that returns nothing at all. This is an execution. When an expression is evaluated, each of the terms inside the expression are evaluated until a single value remains. Here are some examples of different kinds of expressions with comments indicating how they evaluate. 2 is a literal that evaluates the value 2. Hello world is a literal that evaluates the text hello world. X is a variable that evaluates the value held by variable x. 2 plus 3. Operator addition uses operands 2 and 3 to value 5. Function 5 evaluates the return value of function 5. As you can see, literals evaluate to their own values. The variables evaluate to the value of the variable. Operators of addition use operands to evaluate to some other value. We haven't covered function calls yet, but in the context of an expression, function calls evaluate to whatever value the function returns. Advanced rooters expressions involving operators with side effects are a little more tricky. Variable of x initialized to 5. X equals 5 is the side effect of assigning 5 to x, so that's x, obviously. X equals the sum of 2 plus 3, side effect of assigning 5 to x, so that's x, okay. Standard character output outputs the value of the variable x, has side effect of printing value of x to console. That's standard character output. Key insight: wherever a single value is expected in C++, you can use an value producing expression instead, and the expression will be evaluated to produce a single value. Expressions do not end in a semicolon and cannot be compiled by themselves. For example, if you were trying to compile the expression x equals 5, you probably would complain about a missing semicolon, or rather, expressions are always evaluated as part of statements. For example, take a statement. Integer x initialized to the value of 2 plus 3, semicolon. 2 plus 3 is an expression that has a semicolon. The semicolon is at the end of the statement containing the expression. If you were to break this statement down to its syntax, it would look like this: type identifier, so integer, expression. So type identifier, the name, and 2 plus 3. Type could be any value type we choose int. Identifier could be any valid name we chose x. Expression could be any. Oh, what am I talking about? I thought this was just read as one thing, type identifier, but its type is integer, obviously. And the identifier would be the variable's name. And expression would be what it's initialized to. So its expression would be within these brackets here. Expression could be any valid expression we chose 2 plus 3, which uses 2 literals and an operator. Expression statements. Certain expressions such as x equals 5 are used primarily for their side effects. In this case, assign the value 5 to the variable x rather than the value they produce. Limited content. We covered side effects in lesson 1.9 and introduction to literals and operators. However, we mentioned above that the statement cannot be executed by themselves. They must exist as part of a statement. Fortunately, it's trivial to convert any expression into an equivalent statement. Expression statement is a statement that consists of an expression followed by a semicolon. When the expression statement is executed, the expression will be evaluated. Once we can take any expression such as x equals 5 and turn it into an expression statement x equals 5 that will compile. When an expression is used in an expression statement, any result generated by the expression is discarded because it's not used. For example, when the expression x equals 5 evaluates the return value of Operator assignment is discarded, and that's fine because we just want to assign 5 to x anyway. Useless expression statements. We can also make expression statements that compile but have no effect. For example, the expression statement 2 times 3 is an expression statement. The expression evaluates the result value of 6, which is then discarded. While syntactically valid, such expression statements are useless. Such compilers such as GCC and Lang will produce warnings if they detect that an expression statement is useless. We occasionally need to talk about sub-expressions, full expressions, and compound expressions. We occasionally need to talk about specific kinds of expressions. For this purpose, we will define some related terms concerning the following expressions. 2 is a literal that evaluates the value of 2. 2 plus 3. 2 plus 3 is operator plus the value to 5. X equals 4 plus 5. 4 plus 5 evaluates to the value of 9, which is then assigned a variable x. Simplifying a bit, a sub-expression is an expression uses an operand. For example, the sub-expressions of x equals 4 plus 5 are x and 4 plus 5. The sub-expressions of 4 plus 5 are 4 and 5. A full expression is an expression that is not a sub-expression. All three expressions above, 2, 2 plus 3, and x equals 4 plus 5 are full expressions. In casual language, a compound expression is an expression that contains 2 or more uses of operators. X equals 4 plus 5, which is the compound expression because it contains 2 uses of operators. Operator equals and operator plus, which is operator assignment and operator addition. 2 and 2 plus 3 are compound expressions, are not compound expressions. And then quiz time. What is the difference between a statement and expression? Statements and expressions. On a frail, oh my god. Okay, statements in a semicolon and expressions. I don't know, honestly. Let's see this. The difference. Statements are used when we want the program to perform an action. Okay. Expressions are used when we want the program to calculate a value. Oh, okay, so expressions are only used for I already, like, okay, it's like I already knew this, but I didn't know it, if that makes any sense. Like, I knew that, I just don't know it. It's just kind of weird. Like, this is why I'm reading through this thing, going over it, because these sorts of things I already know, but learning the actual, like, meaning and reasoning behind everything makes it just so much more clear to the eye. You get what I'm saying? Or to the brain. So yeah, statements are when we want the program to perform an action. Expressions are used when we want the program to calculate a value. Indicate whether each of the following lines are statements that do not contain expressions. Statements that contain expressions. Okay, so this is just a statement. It's containing expressions, the variable statement. Expression because okay. This is an expression because it has an assignment operator. Statement contains an expression, and its x is a variable definition. The equal is part of the syntax for copy initialization. Initializer to the right of the equal. Okay. And this is a statement. Expression statement x equals 5 is called to operator equals with 2 operands x equals 5. Extra credit foo. Would foo be okay, would a function named foo I think it would have to be, well, it gives a return value. This would be a statement. I don't know. Function calls are part of an expression, so this is an expression. The function calls are expressions. Okay. Extra credit. Standard character output. X hint is a binary operator. Okay, well, let me look at this real quick. Expression statements. Certain expressions such as are permanently used with side effects in this case, standard value and value. Expression statement is a statement that consists of an expression followed by a semicolon. When the expression statement is executed, that's well, this should be an expression. This is not an expression because it's inserting x or the value of x. The binary operator is the standard character output must be the left-hand operand, and x must be the right-hand operand. Since that's the entire statement, this must be an expression statement. Oh, okay. Question number 3: determine what values the binary operator. So standard character output must be the left-hand operator, true, and x must be the right-hand operator. Okay. Determine what values the following program output. So I compile this program. Work through line by line in your head. So this is our type, this is our identifier, and here's the block of code within the function main. So standard character output. 2 plus 3, so this would output 5. What would that be called? I mean, this is just an expression, and then output's a literal constant because it's just hardwired into the code. It can't be changed or anything. We have type x or type integer, identifier x. The expression is 6, so it initializes to a value of 6. Integer y with the expression 6 minus 2, so this would be 4. Standard character output y, so this would be 4. Integer z, they initialize it with nothing, and then they assign z equals to x. So z would equal to 6, and they would do z, so they would do 6 times 6 in the character output, so it would be 36. So 5, 4, 36. 5, 4, 36, okay. It's pretty easy. Developing our first program. We're going on to our first program. Oh snap, it's a long one right here. Alright, I'm gonna leave this for next video. Or I guess I might record some more later and upload it all in one big video. I'm gonna stop recording here. Thanks for watching.